Hello dear students, welcome back to the online class. In today's class, let's start a new chapter, that is study of first element, hydrogen. Okay, so it is chapter 6 of your book. So first, in this chapter, you have to learn about hydrogen. Okay, chapter itself says that study of first element, hydrogen. Under this chapter, you should learn the position of hydrogen in modern periodic table, where it is kept, okay, why it is kept in that position, what are the reasons behind it. Okay, next, how hydrogen is prepared by using various method in laboratory, how hydrogen is prepared in industries, how hydrogen is prepared. So those things you have to learn. Uses of hydrogen, okay, chemical properties of hydrogen, reducing, oxidizing agents, is everything you have to study under this chapter. So let's start step by step. First of all, let's discuss the position of hydrogen in modern periodic table. You are familiar with the position of hydrogen in modern periodic table. So in the previous chapter, chapter 5, in periodic table, I have already explained you the position of various elements in modern periodic table. And you know hydrogen occurs in hydrogen, hydrogen, hydrogen occurs in group 1 and period 1 of modern periodic table. Okay, of modern periodic table. There is along with that is it is kept with alkali, alkali metals, lithium, below that you have sodium, below that you have potassium, below that you have rubidium, below that you have cesium, and ultimately there is francium, Fr. So with these elements, hydrogen is kept. Okay, and there is a controversy regarding the position of hydrogen in modern periodic table. So let's discuss that one. Hydrogen, it is a non-metal, it is a gas. Okay, so it should not be placed with alkali metals which are solid in nature. Lithium, potassium, magnesium, lithium, potassium, sodium, they are all metals. Okay, so hydrogen being a non-metal, it is kept with metals. So that is the controversial part of position of hydrogen in modern periodic table. Okay, there are some points due to which hydrogen is placed in group 1. Okay, let's discuss those points. What a question you write it. What are the similarities between hydrogen and alkali metals? Alkali metals. What are the similarities between hydrogen and alkali metals? It stands for hydrogen. Okay, or what is the reason behind keeping hydrogen with alkali metals in group 1? So answer, write down. The similarities between hydrogen and alkali metals are: number 1, electronic, electronic, electronic configuration, CONFI, electronic configuration. Okay, hydrogen has a similar electronic configuration hydrogen has a similar electronic configuration, hydrogen and alkali metals have a similar electronic configuration. Example, electronic configuration of hydrogen is 1. It has only one electron. Okay. Below that you have lithium. Lithium is 2, 1. Next you have sodium 2, 8, 1. Next you have potassium 2, 8, 8, 1. Next you have other elements are there. So there are 1 electrons in the outermost orbit. See this. 1 electron, 1 electron, 1 electron. Okay. So hydrogen and alkali metals have similar electronic configuration. That's why this hydrogen is placed with alkali metals. Number 1 is that. Number 2, second reason or second similarities between hydrogen and alkali metals are valence electrons. Number of valence ELECT yes. Like alkali metals, valence of hydrogen is 1. Alkali metals, their valence electron is 1. Similarly, hydrogen, it's ALKALI. Okay, valence electron is 1. In the outermost orbit, you will find 1 electrons in case of alkali metals, and you'll find 1 electrons only in case of a hydrogen atom. Okay. So valence electrons means the electrons present in the outermost orbit of an element. Valence electron means electrons present in outermost orbit. You can write, okay, electrons of outermost orbit are known as valence electrons. Next, number 3, valency. Number 3, this one. Number 3, valency. Valency of alkali metals is 1 and hydrogen is also 1. Okay, you write that one. Valency of alkali metals is 1 and the valency of hydrogen is also 1. So that is another similarities between hydrogen and alkali metals, due to which hydrogen is placed in group 1. Okay. Next you have ion formation. Number 4 is ION, ion formation. Ion formation. Like alkali metals, you write it here, okay? Like alkali metals, hydrogen also forms unipositively charged ion. Example, alkali metal sodium, it forms Na1 plus by losing 1 electron. Okay. Lithium also forms lithium Li1 plus by losing 1 electron. In a similar manner, hydrogen also loses 1 electron and it forms hydrogen positive ion, it's plus ion, 1 electron. This electron, okay, symbol of electron. So like alkali metals, hydrogen also forms unipositive ion. Unipositive means 1, uni means 1, okay, unipositive, UNIPO, positive ion, by loss of 1 electron in the general case. Okay, so this is another similarity between hydrogen and alkali metals. Ion formation. Hydrogen forms unipositive ion like alkali metals. Okay, so you should remember this point also. Another, you have reducing power. Alkali metals are good reducing agents, and in Hydrogen also acts as a reducing agent. Okay, reducing power, number, this is number 5, it might be number 5. Reducing, RADUCING, reducing power. Like, you write it here, okay, like alkali metals, hydrogen also acts as a reducing agent. And in support of your answer, you can give this example. If you have copper oxide, CuO, if you have copper oxide, if you pass if you react copper oxide with sodium, Na, then you will get copper plus Na2O, sodium oxide. Okay, in similar manner, copper oxide reacts with hydrogen, H2, to give copper and H2O. See here, copper oxide is reduced to copper. Copper oxide is reduced to copper by sodium. Okay, reduction means removal of oxygen. In simple manner, you can remember that reduction means removal of oxygen. There are some other definitions also for reduction. Okay, for now just remember that reduction means removal of oxygen. See, from copper oxide, oxygen is removed and you got copper, so copper oxide is reduced to copper by sodium. Okay, so sodium is a reducing agent. In similar manner, this here, copper oxide is reduced to copper, reduction of copper oxide takes place. Okay, and reduction is done by hydrogen. Hydrogen reduces copper oxide to metallic copper. So hydrogen also acts as a reducing agent. So alkali metals, they are good reducing agent, and hydrogen is also a good reducing agent. So this is another similarity between hydrogen and alkali metals, due to which hydrogen is placed in group 1 of modern periodic table. Okay, next, you note down this everything. Okay, you note down. Next, burning, burning, burning. It might be number 6. Okay, next, number 6 is burning. Okay, burning. Like alkali metals, hydrogen, you write it here. Like alkali metals, hydrogen also burns in oxygen. And in support of your answer, you can give this examples. Alkali metals, sodium. Okay, let me write about lithium. Lithium plus oxygen will be lithium oxide. It will be lithium oxide, Li2O. This 2 comes from the valence. Okay, this valence is 1 plus this is 2 minus, so 2 goes here. In similar manner, hydrogen, H2. Hydrogen is diatomic, so you have to write H2 plus O2. Hydrogen burns in oxygen to form H2O, water. Like alkali metals, hydrogen also burns. Sodium, Na plus O2 will be sodium peroxide, Na2O2. This is, remember this one. Okay, its name is sodium, sodium peroxide, Peroxide, peroxide. So like alkali metals, hydrogen also burns in oxygen. So that is another similarity. So total we did 6 similarities. Okay, so the 6 similarities will be sufficient for you. Sometimes you will get question like this. So write down the reaction of hydrogen and sodium with say oxygen. How does hydrogen and sodium burns in oxygen? So you should give the last reaction. Okay. And sometimes you will be asked, state two similarities between hydrogen and alkali metals. In that case, you can give any two similarities from the similarities which we discussed just before this one. Okay. Now next question. Discuss the similarities between halogens and hydrogen. Okay. Or okay, it will be solution. Discuss the similarities between hydrogen and halogen and hydrogen. So answer. The similarities between hydrogen and halogens are: number one, electronic configuration. Okay, number one is same like electronic GURATION. Halogens, they have one less electrons in the outermost orbit in order to fulfill the octet criteria. Okay. So hydrogen and halogens have one electron less than that of nearest inert gas. Okay, the hydrogen and halogen have one electron less than the nearest inert gas. For example, hydrogen, say you have fluorine. Hydrogen, it has one electron only. Fluorine, its electronic configuration is 2,7, is 2,8,7. Nearest inert gas is to it is helium. Nearest inert gas to it is nearest inert gas to F fluorine is neon. Nearest inert gas to chlorine is argon. Helium, its electronic configuration is 2. Its electronic configuration is 2,8. It is 2,8,8. So hydrogen has one electron only in its outermost orbit. It has 2. So hydrogen has one less electron than the nearest inert gas, that is helium. Okay. Similarly, fluorine, it has 7 electrons in the outermost orbit, and nearest inert gas to fluorine is neon. It has 8 electrons. Here you have 7 and here you have 8. Neon has 8 electrons. So fluorine has 1 electron less than this. Similarly, this here 7, here 8. There is 1 less electron in this case. Okay, so hydrogen and halogens have 1 less electron. Have 1 electron less than the nearest inert gas. This you should remember. No need to write this one. Okay, you need not to write this. Suppose if question comes, which is the nearest inert gas to hydrogen, then you should say helium. Okay, and if question is like this, which is the nearest inert gas to chlorine, then your answer should be after chlorine there is argon. So argon is the nearest inert gas to chlorine. You should say like that. Okay. Next, valency. Number 2 is valency. Like halogens, hydrogen also has valency 1. Valency of hydrogen is 1, and that of halogens is also 1. Okay. Next, number 3, formation of ion. Formation of ions. Like halogens, hydrogen also forms uni-negative ions. For example, chlorine, it accepts one electron, addition of electron, okay, accepts one electron and forms chlorine 1 minus ion. Fluorine also accepts one electron and forms fluorine 1 minus ion. In similar manner, hydrogen also can accept one electron and it can form hydrogen negative ion. Okay, so hydrogen, it forms positive uni-positive ion also and uni-negative ion also. Like alkali metals, hydrogen can form uni-positive ion, and like halogens, hydrogen can also form uni-negative ions. Okay, so this is another similarities between hydrogen and halogens. Okay, now next, electronegative. Now point number is number 4. Electronegative, electronegative character. ACTR character. Electronegative character means electron pulling character. Okay, like halogens, hydrogen also has electronegative character. It has the tendency to pull electrons towards itself. Okay, electronegative means that. Like halogens, hydrogen also has the electronegative character. Electronegative means tendency to pull electrons, shared pair of electrons. Okay, tendency to pull shared pair of electrons towards itself. Okay, that is called electronegativity. So hydrogen also has electronegative character like that of halogens. Okay, next, physical state number 5, PHYSICL, physical state. Halogens, they are gases and hydrogen is also a gas. Okay, halogens and hydrogen, they are gaseous non-metals. Write on that one. Okay, halogens and hydrogen, they are gaseous non-metals. Next, very important thing, number 6, atomicity. ATOMICITY, atomicity. Like halogens, hydrogen is also a diatomic molecule. Okay, halogens, they are diatomic molecules and hydrogen is also a diatomic molecule. Atomicity means a number of atoms present in one molecule of a substance. Okay, atomicity is that. So when you write hydrogen molecule, you'll write H2. Example you can give just after the sentence. Okay, you can give this example, H2. Chlorine also you can you will write Cl2. Next, fluorine you will write F2. Bromine you will write Br2 and so on. Okay, so they are hydrogen and halogens, they are diatomic molecules. Okay, so that is another similarities between halogens and hydrogen atom. Now next, very important question, discuss the dissimilarities between hydrogen, H, and alkali metals. What are the dissimilarities between hydrogen and alkali metals? You can mix up the points of the similarities between hydrogen and alkali metals, and similarities between hydrogen and halogens. Okay. Point number 1, you can write alkali metals. They are solid. They are metals. Okay, solid metals. Hydrogen is gaseous non-metal. That is the first point. Number two, you can write hydrogen is a diatomic molecule, and alkali metals, they are monoatomic molecules. In their molecule there will only one atom. Okay. Next, number 3, what you can write is hydrogen is electronegative in nature, whereas alkali metals, they are electropositive in nature. That you can write. Okay. Next, number 4, very important thing, oxide of hydrogen. Oxide of hydrogen. Oxide, OXID, oxide of hydrogen, that is H2O, is neutral, whereas oxides of metals, alkali metals, example, sodium oxide, Na2O, they are basic in nature. Okay, so this is the 4th dissimilarities between hydrogen and alkali metals. So number 1 is hydrogen is a non-metal, whereas alkali metals are metals. Okay. Number 2, hydrogen is diatomic, whereas alkali metals, they are monoatomic. Number 3, hydrogen is electronegative in nature. It has tendency to pull electrons. Okay, whereas alkali metals, they are electropositive in nature. Electropositive means they have tendency to give electrons or share, donate electrons. Okay. Next, oxide formation. Oxide of hydrogen, that is water, is neutral in nature, whereas that of alkali metals, it is basic in nature. Now, next question. Dissimilar hydrogen and halogens. Okay, here instead of alkali metals, you make it halogens. HALOGENS, halogens. Number 1, hydrogen has only one orbit, whereas halogens, they have more than one orbits. Fluorine has 2 orbits, chlorine has 3 orbits, and so on. Okay, hydrogen has only one orbit. Next, number 2, you can see oxide of hydrogen, OXID, oxide of hydrogen, that is water, is neutral, whereas oxides of halogens, HALO, for example, Cl2O, is acidic in nature. Okay, ACIDIC, acidic in nature. So 2 points are sufficient. So you note down these questions properly. Okay. Now, we have discussed the similarities between hydrogen and group 1 elements. Okay, similarities between hydrogen and group 17 elements, that is halogens. Next, dissimilarities among them also we have discussed. On seeing all these factors, okay, similarities and dissimilarities of hydrogen with metals and this group 1 elements and group 17 elements, Thomson had suggested, this man had suggested, to keep hydrogen separately in the periodic table, like lanthanides and actinides. They are kept separately in modern periodic table. Okay, just below the table, lanthanides and actinides are placed. So similarly, hydrogen should be placed separately in modern periodic table, and he said, this Thomson said that hydrogen should be placed in a separate box on top of modern periodic table. Okay, whatever is the modern periodic table, it is somewhat like this. It is somewhat like this. Modern periodic table, somewhat like this. So here is the position of hydrogen. Okay, something like this. So Thomson had suggested to take out this hydrogen from this main table and to keep it separately on top of modern periodic table. But his concept was not accepted. Okay, and till now hydrogen is placed in the first position of modern periodic table, in spite of having so many controversies. Okay, now let's move on to another topic, that is discovery. discovery, discovery of hydrogen. Discovery of hydrogen. Now, discovery of hydrogen. Hydrogen was discovered by Henry Cavendish in the year 1766. Henry Cavendish discovered hydrogen in the year 1766, but the name hydrogen was given by Lavoisier in 1783. Okay, Lavoisier, and the name hydrogen was derived from Greek word. Hydrogen means water former. Okay, so when hydrogen reacts with oxygen, it forms water, H2O. That's why this element was given the name hydrogen. Okay, hydrogen means water former in Greek. Okay, and this hydrogen word was quoted by Lavoisier, but hydrogen was discovered by Henry Cavendish. This also you note down properly in your copy. Okay, Henry Cavendish discovered hydrogen, and the name was given by Lavoisier. Okay, hydrogen means water former. Remember that. Halogen means salt former. Halogens means salt former, that we have discussed in previous chapter. Hydrogen means water former. Okay, so when hydrogen reacts with oxygen, it forms water, so its name is given hydrogen. Now